Hello, you are welcome to this class. My name is Dr. Kingsley. In my class today, I'll be taking us on isomerism. Now, what is isomerism? Isomerism is a phenomenon whereby some organic compounds have the same molecular formula but different structural formula. Now, the term isomerism can be used to differentiate organic compound and inorganic compounds. There is no isomerism in inorganic compounds, but some organic compounds, they undergo isomerism. We have different types of isomerism. Isomerism can be broadly classified into two categories. Okay, you have isomerism, okay, divided into structural isomerism, okay, and then you have a stereo isomerism. These are the two broad categories of isomerism. So we can take the first one, which is a structural isomerism. Now, what is structural isomerism? Now, structural isomerism is a type of isomerism in which the two or more isomers have the same molecular formula but differs in structure as a result of arrangement of atoms. Now, the structural isomerism can be divided into four. We have the first one, which is chain isomerism, okay, or if you don't want to call it chain isomerism, it can also be known as a constitutional isomerism, okay. We also have what? Functional group isomerism. Then we have position isomerism. Then we have tautomerism. So these are the four types of what? Structural isomerism. Remember, in structural isomerism, the isomers, they have the same molecular formula but they differ in arrangement of atom. Now, having known the different types of structural isomerism, let us take the first one, which is chain or constitutional isomerism. Chain isomerism, what is it about? Chain isomerism is a type of isomerism in which the isomers differs in the arrangement of carbon atom. Remember, structural isomerism differs in the arrangement of atoms, but chain isomerism differs in the arrangement of atom, which is carbon atom. Now, let me say, for example, when I have CH3, CH2, 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 CH3, okay, this is an alkane having 1, 2, 3, 4, 5 carbon atoms, and that is what? Pentane. What is the molecular formula of this compound? The molecular formula of this compound, we have carbon atom, which is 5, hydrogen atoms is 3, 5, 7, 9, and 12. That is H12. So we have C5H12 as the molecular formula. But this is the what? The structural formula. Now, if I write another compound, which is CH3, okay, CH3, CH2, and CH3. If you look at this compound, you find out that this compound is also made up of what? 5 carbon atoms and 12 hydrogen atoms. What is the name of the compound? This is what? 2-methyl butane. What is the molecular formula? C5H12. Then I can write also another compound with this molecular formula. Something like CH3, CH3, okay, CH3, then CH what? 3. How many carbon atoms? You have 5 carbon atoms. How many hydrogen atoms? 12. So we can now see that what? These 3 compounds, they have the same molecular formula, but their structure, the arrangement of carbon structure differs. So this kind of isomerism, in which the isomers, the different isomers, differs in what? In the arrangement of carbon atom, is what we call chain isomerism. Remember, this is what? 2,2-dimethyl. 2,2-dimethyl propane. Okay? We can have many other ones. Okay? Let me clean this. You can have other ones. Let me say, for example, when you write this, this is a cyclo what? Butane. How many carbons? C4. How many hydrogens? 2, 4, 6, 8. That is a H8. Then, if I write this is a CH3. How many? This is methyl. This is methyl cyclo propane. Okay? What is the molecular formula? We have 1, 2, 3, and 4. 4 carbons. How many hydrogens? How many hydrogen? Hydrogen is equally what? 12. Can you see that these two compounds, okay, they are different in their structure, but in their molecular formula, they are the same. So they differ due to arrangement of carbon atoms. The same thing, okay, can go on with when we have this compound, okay, this is a, okay, cyclohexane. Cyclohexane. The number of carbon atom here is 6. 6 is how many hydrogen? 2, 4, 6, 8, 10, 12. H12. Okay? Now, if I write another compound this way, okay, this is 1, 2, 3, 4. Then I write CH2, CH3. This is what? Ethyl cyclobutane. So you can see that ethyl cyclobutane, we also have molecular structure of C6 and H12. So they have the same molecular formula, but their structure differs due to the arrangement of carbon atom. So that is what we call chain isomerism. So we can move to the next type of what? Of structural isomerism. Let us move. The next form of structural isomerism is a functional group isomerism. So we can go to functional group isomerism to know what it is. Functional group isomerism. What are functional group isomerism? Functional group isomerism is a type of isomerism, or those structural isomerism, in which the two isomers or two or more isomers will have the same molecular formula but differ in structural formula due to the arrangement of what? Of some group of atoms. In this case, we are talking about what? Their functional group. Now, they have the same molecular formula, but they are having different functional group. Let me say, for example, we can take ethanol. Ethanol is CH3, CH2, OH. What is the functional group here? OH. And this is what? Ethanol. Now, ethanol molecular formula is C5, H5, C2, H5, and OH. Then we can have another compound which is CH3, OCH3. This compound you see here is methoxymethane. So we have methoxymethane. What is the molecular formula of methoxymethane? It is also C2, H what? H6O. Yes, C2, you have H6 and O. Remember, if you are writing this one, if you are rewriting this, you can put it as C2, H, we have 5 here plus 1, which is 6, then what? O. Can you see that they have the same molecular formula? But their structure is what? Is different due to the presence of different what? Functional group. This is what we call functional group isomerism. In functional group isomerism, the two isomers differ in their functional group. Another example we can take here in functional group isomerism is, okay, let us take we can take propanol and propanone. What is propanol? CH3, CH2, CHO. This is propanol. Then what is propanone? Propanone is CH3, C double bond O, then we have CH3. So this is propanol. And this is propanone. Let us see. You can see from here that the structures what? They differ. But what is the molecular formula? How many carbon? C3. How many hydrogen? H6. And how many oxygen? 1. O. Come to this place. How many carbon? C3. How many hydrogen? 6. How many oxygen? 1. So their molecular formula is the same, but their structure is not the same. That is functional group isomerism. These two isomers differs in their functional group. Okay. Now we go to the next type of structural isomerism. The next type of structural isomerism that we mentioned is position isomerism. Position isomerism. What is position what? Isomerism. Now, position isomerism is a type of isomerism in which the two or more isomers, they have the same functional group, but the position of the functional group differs. So the arrangement of atom here that differs is the functional group. Let me say, for example, you have CH3, CH, double bond CH, you have CH2, CH what? 3. Now, how many carbon atoms does this compound have? Or let us name the compound first. Now, if you want to number the compound, you number in such a way that the functional group will have the least number. 1, 2, 3. The functional group will be at number 3. But if you start from here, 1, 2, the functional group will be at number 2. So it is better to start from here in your numbering. So we have 1, 2. So this is what? 1, 2, 3, 4, 5. That is pent. Pent what? 2N. This is pent 2N. What is the molecular formula? The molecular formula of this compound, you have 5 carbons, C5. How many hydrogens? You have 3, 2, 5, here 6, 7, and what? 10. So you have H 10. Now let us take CH2, double bond C H. You have CH2, CH2, CH3. If you look at this compound, the second compound, you see that this is what? Pent 1N. Okay, this pent 1N, the functional group is at position number 1. This is 1 and 2. Okay, now if you look at this, you find out that what? That the molecular formula is also how many carbon? 5, C5. How many hydrogen? 5, 7. You have 8. You have 5, 7, 8, and what? 10. That is H what? H10. So you can see two of them here. They have the same what? Molecular formula, but their structure differs. What makes their structure to differ is the functional group, which is the double bond. Here the double bond is at number 2. Here the double bond is at number what? Number 1. That therefore you can also have what? hex 1N, hex 2N, and hex 3N being isomers. What differs is the position of the double bond. The same thing, if you have CH2, 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 CH3, okay, CH3 here, CH3, CH2, CH2. Now, if this is CH2 and there is OH here, this is what? This is a both 1 all. If you have CH3, CH, OH, then CH2, CH3. This is what? Both 2 all. So both 1 all and both 2 all, they are isomers. Now, how do they differ? The position of the functional group. The functional group is what? Hydroxy group, OH. Is our position number 1 here, while the other place is our position 2. Now, we have been able to know what position isomerism actually is. So, in structural isomerism, we have explained chain isomerism, functional group isomerism, and position isomerism. The last for structural isomerism is tautomerism, is what we call tautomerism. Tautomerism. So we go to what? Tautomerism. What is tautomerism? Tautomerism is isomerism type in which the 2 or more isomers we have the same molecular formula, but they exist in dynamic equilibrium. They exist in dynamic equilibrium as a result of movement of what? Of atoms. Now I can take an example here to show. So when we have C double bond C and we have H and what? H here. You have H and what? And the OH here. Now this is a compound. Okay? It's a compound. Okay? Now look at the structure of this compound. What is the molecular formula? Count the number of carbon, which is C2. Count the number of hydrogen, which is what? H4. How many oxygen? O. Now this hydrogen here, I mean this one, can actually do a 1-2 shift to come to this place. This hydrogen can be shifted to this place. If we do so, what we will have here is what? CH, we have H and what? H. Then you have a C, H, double bond O. All right. Because of the movement of what? Of this group to this place, the double bond here will break, while double bond will be introduced here. Now, what is the molecular formula here for this compound? Is also what? C2 and H what? 4O. So this one is having the what? The hydroxy group. That is why this compound is called the enol. Why this one is having what? Double bond, C double bond O, which is a ketone functional group. That is alkanone functional group. That is why we call it keto form. So any enol form of a compound and the keto form of the same compound are what? Are isomers. So this exists. Tautomerism exists in a enol and keto form of a compound. It also exists in amino and imino forms of what? Of a compound. That is where you find tautomerism. Now we are through with the structural isomerism. So we can go to the stereoisomerism. Now, what are stereoisomers? That is where we should start before we take example. Stereoisomerism. In stereoisomerism, the 2 or more isomers have the same molecular formula. Okay, that is established. But they differ in spatial arrangement of atoms or group of atoms. They differ in spatial arrangement of atoms, or they differ in orientation of atoms in space. Now we have 2 types of what? Of stereoisomerism. The 2 types of stereoisomerism is geometric isomerism Okay, and we have the optical isomerism. Okay, the geometric isomerism is divided into two. We have a cis and trans isomers, cis and trans isomers. Okay, all right. So sorry, example. I'm supposed to be taking examples of a geometric isomerism is what? Cis and trans isomers of compounds. So anytime you hear cis and trans form of isomers, please know that is a geometric isomers. What are geometric isomerism? We say cis and trans. How do we have cis and trans isomers? Now, cis and trans isomers exist when there is what? Double bond, most times. Because double bond does not allow free rotation. Okay, so the compound are locked up. Now, let me just give an example to show what I'm saying. Now, let us say we have the compound, okay, C double bond, C, okay, CH3, okay, we have CH3, and we have a Cl, and we have what? Cl. Now, what is the name of this compound? Let us number the carbon. 1, 2, 3, and what? 4. So it's coming from the parent but, which is butane. But chlorine atoms are attached at number 2 and 3. So what will be the name of this compound? Now, before we name the compound, we must establish, for example, that the chlorine atoms are what? At one location. The chlorine atoms are the upper location. So anytime the atom that are in spatial arrangement is at the same position, we call it what? Cis. So this is what? Cis 2, 3, or cis but. Cis but 2, 3. Okay? Cis but 2, 3. Cis 2, 3 dichlorobutane. Okay? Alright. Cis 2, 3 dichlorobutane. Cis 2, 3. Okay? Why the other one is trans 2, 3 dichlorobutane. Alright. So this is what? Cis 2, 3 dichlorobutane. Alright. Now let us compare it with this compound. C double bond C. We have CH3. Then here we have Cl. Then this is a CH3 and we have Cl. Okay. If you look at these two compounds, you'll find out that what? The number of carbons, the number of hydrogen, and number of chlorines are the same. So their molecular formula is the same. But you can see that what? The chlorine are no longer at the upper part. One chlorine is up while one is down. So anytime the atoms were in question are what? Not at the same part, we use the word trans, okay, to denote it. So this is a trans 2, 3 dichlorobutane. All right. So that is the name of the compound. So the cis form of this compound and the trans form of this compound, they are isomer. What kind of isomerism? We call them what? Geometric isomerism. I will take one example in geometric isomerism. Let's say we have CH3, okay, H, then we have CH, then CH to CH what? 3. Okay, this is cis pent 2N. Pent in that if you number, you have 1, 2, 3, 4. 1, 2, 3, and what? 4. So look at the atoms that are in question. These two atoms is what we are considering. They are this at what? At the same side. So this is a cis pent 2n. 2n. Now consider it with the other one here. Let's say we have C, CH3, H, then C, we have H, and what? CH2, CH3. If you consider it, the two atoms here are at the same side. That is why it says, why these two atoms? One is up, why one is down? That is why we call it what? Trans here. So this is trans what? Trans pent 2n. So cis pent 2n and trans pent 2n, they are isomers. What kind of isomerism? We call it geometric what? Isomerism. Now, the last form of stereoisomerism is optical isomerism. So that is the last we have in this class, optical isomerism. We call it optical or optical isomerism, or we can call it enantiomerism. Enantiomerism. This compound that are optical isomers, what we know them with is that they can rotate the plane of polarized light. So they have effects on polarized light. That is why we call them optical isomerism. So optical isomers can be called enantiomers. We can call them enantiomers. Optical isomers. So optical isomers are those isomers that can rotate the plane of polarized light. They are usually mirror image of one another. For example, when you bring your left hand in a mirror, it will seem as if it is what? Your right hand. Therefore, they are mirror images of one another. And mirror images can never be superimposed. So they are not superimposable. They are not superimposable to one another. Now, how do we know optical isomers? Optical isomers, we always have what we call the chiral carbon. Chiral carbon. What is chiral carbon? Chiral carbon atom are those carbon atoms that have 4 different attached groups. Let me say, for example, you have a carbon atom and you attach A, you attach B, and you attach C here, and attach what? D here. You can see that what? A, B, C, and D, they differ. So this carbon atom in which these different groups are attached is known as what? Chiral carbon atom. But when I have carbon atom, I attach A, here I attach B, I attach C, and I attach A. You can see that there is repetition here. A is being repeated. So this will not be chiral carbon. And if it is not chiral carbon atom, it is called achiral. Remember, you either have chiral carbon atom or achiral carbon atom. Optical compound, they have what? Chiral carbon atom. While non-optical compound, they have a chiral carbon atom. Now, let me take example using an organic compound. Alright. So when I have a carbon and I have OH attached, here I have what? CH3 attached. Here I have what? Cl attached. And here I have hydrogen attached. You can see that this carbon atom is what? Is a chiral carbon atom. Why? Because the groups that are attached, none of them is what? None of them are the same. So this carbon becomes what? A chiral carbon. So this compound is what? Is an optical active compound. Now, another example I have here is, of course, CCl. I have H, and I have CH2, CH3, okay, and CH what? 3. 2-chlorobutane. This is a 1, 2, okay, 1, 2, 3, and 4. So this is 2-chlorobutane. 2-chlorobutane. Okay, you see that this is a group attached here, this is another group, and this is another group, and this is another group. So you can see that what, that compound is optically active because this carbon atom is a chiral carbon atom, because it is having what, it is having different attached group. Now, optical active compound can rotate the plane of polarized light either to the left or to the right. If the rotation is to the left, we call that rotation lavorotatory. If the rotation is to the right, we call that rotation dextrorotation. Dextro means right, while lavo means left. So, and they are what? They are non-superimposable because they are what? Mirror image of each other. I believe that you have enjoyed this class on isomerism. And if you have, science must improve. So you need to make sure that this video get to other persons that will need it. So what you need to do is to subscribe to this video, like the video, and share it to people that are writing A-level exam, WAEC, GCE, NECO, okay, NAPTEL, then first year students, and so many of them like JUPEB. So share the videos and let it get to people that need it. My name once again is Dr. Kingsley. Thank you very much because you have taken this class.